Hi, today I want to talk with you about functions. And the way to think about functions is that functions are the machines of mathematics. They have inputs and they have outputs. And let's just take a look at the example that's given in your textbook, example 3, the softball toss. This is on page 191. But what this tells us, and we're going to talk through what all this means. So this says h of t equals 32t minus 16t squared. And then it goes on to say that there are some limits on t. Okay, now what's going on here is Kendra is tossing a softball up and down in the air. Kind of just standing there and tossing it straight up in an underhand motion. And somebody else has got a camera or some such thing that is recording the height of the softball as a function of time. And then they figure out this equation. Now, maybe this was part of a physics class. It really doesn't matter. But what I want to talk to you about is how to handle functions. So this function notation, this h of t bit right here, that's just a way of giving this equation a name. We're talking about the height of the ball, so we named it h. We could have named it height. We could have named it George. We could have named it Filippo. H is easier to write, so we write h. H is the name of the function. Now the next part, the parentheses t, indicates what the variable is. So this does not mean h times t. This means h of t. Okay? Now, on the other side of the equal sign, this defines this statement over here, this 32t squared minus 16t, or sorry, 32t minus 16t squared. This defines the relationship between the function h, which depends on t, and the variable itself, t. Sorry, let me scoot this over a little bit, see if I can get it better. There we go. Okay. So this is kind of the same thing as saying y equals. So if we were to say that y is the height of the ball and x is the time, because t is time in seconds, then this would be exactly the same thing as saying y equals 32t minus, whoops, sorry, I want x's. 32x minus 16x squared for x between 0 and 2. Those are equivalent statements. Means exactly the same thing. So why do we use function notation? Well, we use function notation because it's just a shorthand way of writing stuff, and that'll come clear in just a second. Now, when we're using, let me put that back. When we're using the y equals form, suppose we want to know how high the ball is at 1 second. We would say, find y when x equals 1. The function way of saying that is to say find h of 1. What we're saying when we write this bit, when we write out h of 1, what we're saying is replace all your t's with 1. So h of 1 is going to equal 32 times 1 minus 16 times 1 squared, which is 16. So that means that the ordered pair, t comes first, because it is what we call the independent variable. It's the thing we plug in. 116 is on the graph of the path of that ball. Okay. Oh, you can't see the 16. There's a 16 right here. Sorry. So what I want you to understand is how to evaluate a function at a value. And that's what we just did. We just evaluated h of t at t equals 1. Okay. There's some more stuff we want to know about functions. And I'm going to stick with this guy. I'm going to make a graph of this real quick. So what I'm going to do, or what you would do, is plug in different t values and find different h values, just like they did in your textbook. I'm actually going to use a graphing utility called Desmos. So this is a graphing utility that I recommend you become familiar with. It will help you out in doing your homework. And there is an app that's available for it for any Android device, or you can access it on the computer like I just did. And what I'm going to do is I'm going to use the y equals form, because that's what Desmos likes. 32, and I will put the link to Desmos in the webliography section of eCompanion. So now let me adjust my screen a little bit here. So this red line represents the path of the ball. So I'm going to adjust this just a little bit so that I get, we've said that Rx only goes from 0. Alright, I want to do this from 0 to 2. And I'm going to see if I can make it step at 0.25. There we go. So the way this works is the 0 is clear down here. It's kind of off the screen. Let me just adjust my zoom so you can see my whole screen. That's better. Okay. So the 0 is down here in the corner. Let's see if it'll let me have it. There we go. Okay, I'm going to put this in our spot that I'm writing on. All right. So, now remember, this isn't the path through space. What this is we've got time in seconds down here on the x-axis and height up here on the y-axis. But what shape did this make? So it made a parabola. And we tested a minute ago, we plugged in t is 1, and we said the height should be 16. Is that what we find? Well, here's t is 1. Here is y is 16. And sure enough, that point is on the graph. So you can plug in different values and find different heights. For example, if you plug in 0.25, you'll find so a quarter of a second from the time the ball leaves Kendra's hands, it is 7 feet in the air. Okay. So why did we only go from 0 to 2? Well, remember what's going on here. The ball's in Kendra's hands. She, at time 0 is when she tosses it, and she catches it again at 2 seconds. So it only makes sense to talk about the time that the ball is in the air between the time when she tosses it and when she catches it again. Now, I told you at the beginning of this little talk that functions have got inputs and outputs. T is the input. That's what we put into our function, what we plug in. What we get out is the height. And so that, the same thing that is the h of t is the output. Okay? Now, in functions, we have special names for these, regions. So if we think about the numbers that we are allowed to put into this function, in this case, it's any number between 0 and 2. So this portion of my x-axis, that's just one region of the x-axis, right? That region is called the domain. The domain of the function is the region of the x-axis that we can input into the function. Or another way of saying it is it's the set of all numbers that we can plug into a function. For polynomial functions, and this is an example of a polynomial function, the domain will be all real numbers. Now, the numbers that we get out we can only get out numbers between 0 and 16 on this example. The ball never goes any higher than 16 feet or any lower than 0 because we've marked 0 as the height of Kendra's hands. The numbers that we can get out are the portion of the y-axis that's included in the function when we graph it. Those two have a name. This is the range. So for this function, the domain is all real numbers. Now, we're going to use interval notation quite a bit in this. Actually, the domain is not all real numbers. The domain is any number between 0 and 2. So it's 0 less than or equal to t is less than or equal to 2. The range are the y's that we can get out, which in this case is 0 less than or equal to h less than or equal to 16. Okay. I'm at my 15 minutes, so I'm going to stop here, and I will then create another one of these talks to talk about the difference between functions and relations and how we use the vertical line test. So I'll be back in a minute.